So in the last class we are going to discuss the dot product and cross product. So we will start from that only. There are two types of product defined between two vectors. First one is called a dot product, whose result is a scalar quantity. Suppose this one is a vector A, this one is a vector B, and the angle between them is defined as theta. Then dot product A dot B is defined as magnitude of A, magnitude of B into cosine of the angle theta between them. Cosine of the angle theta between them. Now, what is the significance of this product? And we can think of it as if the component of vector A is taken along the direction of B, this much. What is the length of that part? A cos theta. So you can think of that A dot B means you have to take the component of A along the direction of B, then multiply by the magnitude of B. That defines the dot product between two vectors A and B. Someone can say that I will take the component of B along the direction of A. So for that he has to draw the perpendicular over this in this way. Now see, he will define this length as B cos theta and will write I am calculating B dot A and it will be B cos theta, the component of B along A multiplied by magnitude of A. But in either case the result is same, means A dot B and B dot A will give you the same result. So this product is commutative in nature. Okay, so we can write A dot B equal to B dot A. A dot B equal to B dot A. Right? Now, whether you are taking the component of A along B or you are taking the component of B along A, that does not matter. So since it is a scalar quantity, so whether you are going from A to B or B to A, that does not matter. So the result is a scalar. Now from this dot product, we can find many things. If the vectors are given in component form, in 3D suppose Ax I cap plus Ay j cap plus Az k cap. Similarly, vector B is given Px I cap plus Py j cap plus Pz k cap. Then you can readily write the dot product of these two as Ax Bx plus Ay By plus Az Bz. Because first term Ax Bx you have to write I dot I, and then following this rule I cap means magnitude is 1. Second one is also I cap, in that case I dot I if I am calculating, then B is also 1. And what is the angle between I with I? Both are along x-axis, so angle between them is 0 degree. So in that case cos 0 will be 1 and you will get I dot I will be 1. Similarly J dot J will be 1, K dot K will be 1. But if I calculate I dot J, then I is along x-axis, J is along y-axis, angle between them is 90 degree. So cos 90 will come and I dot J will be 0. So because of this commutative property, J dot I is also 0. So whenever the two unit vectors are seen, their dot product will be 1. Whenever they are perpendicular to each other, their dot product will be 0. So we can say that if two vectors are perpendicular to each other, any two vectors are perpendicular to each other, then their dot product will be 0. Now, if I try to calculate A dot A only, then B is replaced by A, so I will get AX square plus AY square plus AZ square, and A dot A means magnitude of A, B is also A, so it will be A square cos 0, because A is along any direction, another vector you are taking same A, so they have no angle between them, that is angle is 0 degree. So you will get only A square equal to AX square plus AY square plus AZ square, and from this, by taking the square root, positive square root, I can find the magnitude of the vectors, that is A equal to root over of AX square plus AY square plus AZ square. The same relation we have derived in the last class by using the direction cosines, cos alpha, cos beta and cos gamma. Okay, now dot product is used to calculate the angle between the two vectors. Whenever you try to find the angle between two vectors, you can use the dot product, because from this statement we can write it is equal to AB cos theta, it is AX BX plus AY BY plus AZ BZ. Now remember, if vectors, these two vectors are given in this component form, suppose 2i cap plus 3j cap minus b cap, and b is also represented like this. In that case, you can perform the dot product. You can calculate the magnitude of A and magnitude of B by this formula, and then dividing this one, you will get the value of cos theta. So once you get the value of cos theta, then you can find the theta as well, that cos inverse of that value. Okay, so whenever there are two vectors in component form, it is given, and you are asked to calculate the magnitude of the vectors, you have to use the dot product. Clear? Now we will discuss one problem. Write down. Vector A is given A square I cap plus A j cap minus k cap. Vector B is given I cap plus j cap minus plus 2k cap. This is your vector A, this is your vector B. Right? Find the values of, write down, find the values of small a. Find the values of small a such that the vectors are perpendicular to each other. Vectors are perpendicular to each other. Find the values of small a such that vectors are perpendicular to each other. See, how to solve this problem? First you have to do the dot product by this rule. AX BX. Now what is AX in this case? A square. BX is 1. So first term AX BX will be A square into 1, that is A square. So I can write here. So I want to write this side. It will be A square, first term. Next term will be AY is small a, BY is again 1. So A into 1. A last term minus 1 into 2, that will be minus 2. And this side of the product is AB cos theta. What is given? Vectors are perpendicular to each other. So theta becomes 90 degree. theta 90, so cos 90 will be 0. So now just middle term factorization and you can find the value of it. Product, two vectors are perpendicular mentioned in the problem. So A dot B should be 0 because cos 90 will come, cos 90 will be 0. So A dot B means this side will be 0, this side A dot B will be 0 and this side will be Ax dx plus Ay by plus Az bz. So accordingly we construct Ax dx a square into 1, that is a square, plus Ay by a into 1 plus Az bz minus 1 into 2, that is minus 2. So we got this equation. Now we have to solve to find value of A. This is a quadratic equation. Find the value of A. So it will become A square plus 2A minus A minus 2 equal to 0. So A common, A plus 2 minus 1 common, A plus 2 equal to 0. So it is coming A plus 2 into A minus 1 equal to 0. So A equal to minus 2 comma 1. Two values are possible. So this is one type of product where the result will give you a scalar quantity. There is another type of product where you will get a quantity which is a vector because it has some direction. That is the cross product. And in last class we discussed that these are the vectors related to some rotation, because these are axial vectors. After the cross product what we will get is actually an axial vector. Now what is axial vector and all these things we will discuss. This is vector A, this is vector B. And angle between them is defined as theta. Now check, I have given an arrowhead in the theta to show it is anti-clockwise sense. It is in anti-clockwise sense means you have to go from direction of A towards the direction of B. Okay? Now if you are going from direction of A towards the direction of B, which hand we will use to define this rotation? Always the right hand. So you have to place your 4 fingers of this right hand along the direction of vector A, and then you have to rotate this one towards the direction of B, and in that case your thumb will show the direction out of the board. Okay? So that direction is defined as the direction of this cross product of A and B, and it is defined as A cross B equal to magnitude of A, magnitude of B into sine theta, where theta is the angle between them, and there is this symbol n cap. Now n cap means unit normal vector. N cap means unit normal vector, which means a unit vector perpendicular to the plane containing A and B, which means an unit vector perpendicular to the plane containing A and B. Clear? But this definition is not complete, because perpendicular to the plane containing A and B, we can draw the unit vector along this direction, we can draw the unit vector along this direction. But which one we will take? That is guided by this right hand rule. Right hand rule is saying that outward drawn normal will be the direction of the n cap. Its direction will be the outward drawn normal when you are rotating from A to B. Clear? So in two-dimensional case, this A cross B is shown like this, and to produce a 3D sense we can use this type of symbols, that A and B is there and A cross B is in the direction perpendicular to both A and B and given by the right hand thumb rule. Right hand thumb rule always. And this right hand thumb rule will tell you if you are going from A to B, the thumb will show the direction outward from the board, not the inward. So end cap is directed, defined in this way. Clear? Now obviously if you are going to calculate B cross A, the finger will go inside the board, means it is changing the direction. So if you are calculating B cross A, your finger will be inside the board, right? So B cross A in this diagram we can show in this way. It has the same magnitude but direction is opposite, downward. So if along this direction unit vector is defined as plus n cap, then in the opposite direction it is defined as minus n cap. And similarly we can write B cross A equal to minus of AB sin theta n cap. So clearly you can see that A cross B will be equal to minus of B cross A. Hence this product is not commutative. It is sensitive on the direction, whether you are going from A to B or you are going from B to A. It will change the direction. Now if two vectors are parallel to each other, then their cross product will be always 0, because sine 0 will come and sine 0 will be 0. So remember one thing, if it is asked that two vectors are perpendicular to each other and you have to calculate something like the previous problem, we will always try to use dot product. If two vectors are parallel to each other, then we will always try to use cross product, because for perpendicular vectors dot product will be 0. For parallel vectors cross product will be 0. That's why when we are discussing a problem in the last class, I said that if you can solve this problem by all the product rules, but if you use the dot product you have to face a long calculation, because in parallel vectors dot products is not 0. So that's why the calculation will increase. So that's why in the last class problem cross product is more easier than the dot product. And even we found that in case of parallelism, the multiplication of a vector by a scalar is much more easier than all these product rules. So calculations will be least in that case. That we have solved to calculate the values of A and B in the last class, one problem we have discussed. Okay? Now, if the vectors are given in component format, then how to calculate the cross product? There is a simple rule of determinant. You can remember this one. This determinant will give you the calculation of the cross product. If two vectors are given in component form, that is ax plus I cap plus ay j cap plus az k cap, similarly b is given. So by taking calculating this determinant, you can find the value of the cross product. How to calculate its value? Suppose I cap is there. So the row and column that is containing I cap has to be closed. Both of them are closed. Now you have four covectors, AY, AZ, BY, BZ. So you have to product in this way. Just follow the direction. AY, BX minus AZ, AY, BZ minus AZ, BY. So AY, BZ minus AZ, BY. Then J cap. So J cap containing row and column should be off. But now for the next term, the direction of this product is reversed because I use the positive sign before J. So stop this. Four cofactors you can see, AX, BX, AZ, BZ. Now the direction will be reversed, not this one. It is this one. So AZ, BX minus AX, BZ. So AZ, BX minus BZ, AX, BZ. Okay, just reverse order. Previously like this, now like this. Then the third one, K cap. It is again similar to the first one. So only in the middle the direction will alter. First one is K cap row column stop. This four quantity AX BY minus AY BX. AX BY minus AY BX. Complete. So only for the middle J the direction will alter, otherwise the direction for first and third direction will remain same. This technique you have used I think in class 9 or 10 when you are studying the cross multiplication technique to solve the simultaneous linear equation. Now, and you have to remember here one relation that is useful for solving vectors problems and in case of motion, in case of equilibrium of forces, and in all these cases that problem is utilized. That technique will be utilized to solve the problems quickly. In trigonometry, the sine rule. Suppose this side is of length A. This is B, this is C. Length of the sides A, B, C. The opposite angle of A is given alpha. Opposite angle of B is given beta. And opposite angle of C is given gamma. Then the sine rule says that A by sine alpha is equal to B by sine beta equal to C by sine gamma. This one is called the sine rule in trigonometry. For any right and any triangle it is valid. If the three sides are A, B, C and opposite angles of A, B, C are alpha, beta and gamma, then A by sine alpha equal to B by sine beta equal to C by sine gamma. We can prove this by using the cross product. So in trigonometry this is called the sine rule. When you draw the vectors, you will represent vector by a line segment where we consider that the magnitude of the vector is proportional to the length of the line segment. Then if I represent all these sides by vectors, suppose this one is a force vector F1, this one is another force vector F2, this one is another force vector F3. Then taking their magnitudes, we can write this form as well. F1 by sine alpha equal to F2 by sine beta equal to F3 by sine gamma, F3 by sine gamma. Now check, what is the sum of all these forces? 0. F1, F2, F3 all are represented by the triangle, sides of a triangle taken in same order. So their resultant will be 0. So under the action of these forces, we can consider the particle is in equilibrium because the net force is 0. In that case, it is called Lami's theorem. Lami's theorem. In case of studying the equilibrium of the bodies under the action of three forces, the same rule is written in terms of force and called Lami's theorem. And in trigonometry, it is simply called sine rule. So the sine rule and Lami's theorem, these are not different, same thing. Once it is represented in terms of the magnitude of vectors, and in trigonometry it is denoted in terms of the length of a side. But this is not required always in solving the problem of the equilibrium under the action of forces, because we can use the vector resolution also to solve those problems. But in some problem we can use this technique to find the answer quickly. Okay? Now, this vector part is almost complete, and I will give you one more numerical at the end of this vector part. Then we will go to the kinematics portion and motion and all these things. How many of you know to calculate the derivative? Little bit of derivative. Okay. I will show you, I will write one formula. That is the product rule of derivative. Not more than that is required for solving this problem. See, suppose it is asked to calculate d dx of uv. This is called the product rule of derivative. d dx of uv, where u is a function of x, v is a function of x, and you have to calculate the derivative of this product. It may be u equal to x and v may be sin x. Now the rule says it will be u dv dx plus v du dx. So you have to take the derivative of one function taking other function constant, then derivative of the other function taking the next one constant. First function fixed, derivative of second function, their multiplication, plus second function fixed, first function's derivative, multiplication, and then add. This is called the product rule of the derivative. Now I will give you one problem. Write down. Capital A vector, over arrow over there. Capital A vector has constant magnitude. Capital A vector has constant magnitude. Okay. Then A dot capital A dot DADT will be capital A dot DADT, capital A dot DADT means derivative of capital A will be how much? 0. Why 0? Cos 90 will come. How to prove it? Capital A is a vector of constant magnitude, means capital A dot capital A. This will give you A square. Capital A dot capital A will give you A dot A into cos 0. Cos 0 is 1. So it will be A square simply. But it is mentioned in the problem that magnitude of capital A is constant. So this A square on the right hand side will be constant. So I will take the derivative with respect to time. ddt of A dot A. That is coming 0. Because derivative of constant quantity is 0. Now, use this rule. Here U and V both are A. So I can write A dot DADT plus A dot DADT, because dot product is commutative, so nothing to bother with the direct which one is taken first or second. So we are getting 2A dot DADT, that is coming 0, means A dot DADT, that is 0. So these are two vectors. One vector is A, another vector is DADT. Their dot product 0, means they are perpendicular to each other. Okay. Now can any one of you tell me what is the application of this one in mechanics? You have already studied it in class 11, its application. Instead of A, if I consider vector is R, that will be more familiar notation to you. Uniform circular motion. R is the position vector of a particle moving in a circle. So will the magnitude of R change? No, because a circle's radius is fixed. It will never change. So we can write that R dot R will be R square, which is constant, and you will finally get to this result. Where dRdt means velocity, instantaneous velocity, and R is the position vector. Now see, this is the circle, this is the position vector at any time. Then dRdt is along this, that is V, that is called the tangential velocity. So velocity is always tangent to the radius, that is to the path of the circle at any point. That is the case of uniform circular motion. So it is utilized in that case. If someone asks you that how to show that velocity is tangential in a circular motion, uniform circular motion, velocity at any point is tangential to the path. So you have to start from that magnitude of the radius vector is always constant, because circle means radius cannot change. So start with that R dot R equal to R square, which is constant, take the derivative and show that R dot dRdt equal to 0, means R dot V 0. So R is perpendicular to V, so R is along radius and perpendicular to radius is tangent only. Now we are going to discuss a little bit about the mechanics part. Now Mechanics means the science of motion. So there are two cases obviously. One is the no motion, that is rest. Another is moving with some velocity, with increasing velocity, decreasing velocity, and all these things. Now how many procedures are there to study? One is kinematics, another is dynamics. Can you tell me what is the difference between kinematics and dynamics? Okay, I will tell you one story. Suppose you have performed Saraswati Puja and or any puja in your home. Okay. Suppose in any puja in your home, it will be in the morning and priest is telling that all of things are ready, and now suddenly the priest called and said, I will be 1 hour late. All the quantities are already given in front of the idol and everything now prepared. Now suddenly your parents said that no one will enter the room. I will prepare all these things. After the priest will come, puja will be performed, and then the prasad will be given. Right? Now suddenly there was a sound from that room. Your parents rush to that position and see that there is something sweet or anything is there, and you are almost close to the sweet. What they will feel? You cannot stop yourself. You will be scolded, you will be beaten. After the prasad giving, after the puja, everything will be given. You cannot wait. All blame will be on you. Okay? So this thing is what happened in front of your parents' eye, and they took the decision that you are in front of the sweet, means you are going to steal it. So eyewitness is the only decision. Now suppose after something you have to be given to, you are taken to your father for a good scolding is not enough. You must be beaten. So your father asked him, why you entered that room? You said, no one is allowed to tell me anything. I entered that room because some cat is entering that room and he will destroy all these things, and only to remove him from that room, I entered the room. Now, is there any beating to you? If it is true, no one. So, first parent, when he took the decision, he took on the basis of what he see. But the second one, your father is taking the decision by what is the cause due to which you entered the room. The same thing occurred in mechanics. You see a motion in front of your eye and you immediately start to predict what is going about the motion. But what cause is behind this type of motion, that is not analyzed in kinematics. So kinematics is like the first one, like mother, who is seeing everything in front of eye and immediately took the decision, like the first case. So without knowing the cause, describing motion is done in kinematics. But in dynamics, you have to describe the motion by knowing the cause, that is force. Clear? So this is the broad distinction between kinematics and dynamics. Now, in kinematics, in rest and motion, some concepts are there, rest and motion and all these things. But these concepts are completely related concepts. Means this building, is it at rest right now? Who said? With respect to which? I am asking with respect to the moon. With respect to moon, this Earth is entirely moving. So this building is also in motion with respect to the moon. So rest, if I said that this building is at rest with respect to the Earth, then it is true. If I said that this building is in motion with respect to the sun, that is also true. So rest and motions are relative concept, and the observer with their reference frame can predict about the rest and motion of the particle. Or any object or a particle can be at rest and in motion simultaneously with respect to two different observers who are using different reference frames. Means reference frame is of very much importance. What is taken as the reference frame? Earth is taken as the reference frame. A nearby building is taken as the reference frame. A moving car is taken as the reference frame. Or moon is taken as the reference frame, and all these things. Clear? Now, so these two concepts, reference frame, relativeness of the rest and motion, is the beginning. Now we will define some kinematical quantities, because we will not discuss the cause of motion force right now. So we have to define some geometrical quantities only to describe the motion. Suppose a particle starts from here and goes up to this point. So he is following this path entire up to this point. So the total length of the path traveled by the particle is called the distance traveled. It has no specific direction. It has no specific direction. So it is a scalar quantity. So distance traveled is a scalar. But if we consider the shortest distance connecting initial and final point, then this distance is denoted by S. It has a specific direction. It is called a vector quantity. So whenever there is a vector, I will put an arrow bit over it. So distance traveled is a scalar, but displacement is a vector. Now, tell me one question, that is, in which type of motion magnitude of displacement is greater than distance traveled? In which type of motion? There are many types of motion. Motion along a straight line, motion along a circle, motion, oscillatory motion, all this periodic motion. So in which type of motion the magnitude of displacement is greater than distance traveled?
There is no motion.
There is no motion. Because displacement is the shortest distance between 2 points. So shorter than that cannot be possible. So displacement is always the shortest between two given points. Clear? Now, if in traveling from this point to this point, particle takes certain time t, then we can define one quantity, that is distance traveled by time, which is called speed, and displacement by time is called. Both the terms are wrong. Both the terms are wrong. Average speed and average velocity is the actual term, because in a certain time a certain distance is covered, then this d by t will give you total distance by total time. Meanwhile, whatever be the speed of the particle at different points, you don't know, means you are calculating the average. So this is called average speed. This is called average velocity. Okay. Now, the velocity of the particle can even change. It can change both in magnitude and direction. And whenever there is a change in magnitude and direction, we consider the vector is changed. So this change in velocity vector per unit time, that is called the rate of change of velocity vector, which is called the acceleration. So generally it can be written as A equal to V minus U by T. It is taken as the acceleration. Now, what is U? Initial velocity. V? Achha, if I ask you what is initial velocity? Anyone? What is initial velocity? Yes? Object starts moving. Okay. Asha, if I say that initial velocity is 10 meter per second, what does it mean? Starting from? Asha, okay. Initial velocity curve is 10 meter per second. Means it starts with 10 meter per second. So in the garage, car is still moving. Whenever any car is in the garage, it is at rest time. Initial velocity does not mean the velocity with which an object starts, and final velocity does not mean with which the car stops. Then what are the concept of initial and final velocity? Suppose everything is based on the observer. In kinematics or in mechanics, everything is explained by some observer by choosing proper coordinate system as a reference frame. Suppose a car is there, car is not yet started, and suddenly it starts. An observer sees all these things. So what is the initial velocity of the car? 0. Suppose the car has already started, but the observer not yet observed it. The car's velocity increasing due to acceleration, and now for the first time observer sees the car. He will say that at the beginning of the observation, the velocity of the car recorded by the observer is called the initial velocity, and that is now 10 meter per second. So whenever a finite value, non-zero value is given, means the observer starts his observation at that point. That is called the initial velocity. Suppose the car is going and observer observe the car for the last time, and after that he don't care what is happening. So last time observed velocity of the car by the observer is called the final velocity. These are the ones. It may move after that. It may stop after that. Nothing else. The last time recorded by the observer. If observer sees the stopping, he will say that final velocity will be 0. So write down initial velocity and final velocity means the first and last velocity recorded by the observer. First and last velocity recorded by the observer. Not the velocity of starting or ending. Okay? Now, so these are the initial concept, and after that we will try to solve some problems after deriving the equations of motion along a straight line. Suppose this room is a perfect cube. Though it's not a perfect cube, it is a cuboid. Let us consider this room is a perfect cube. Okay. Having length, breadth and height each 10 meter. 10 meter, 10 meter, 10 meter. So what is the diagonal of the room? That corner up to that corner. This is the diagonal of this cube. So what is the length of that diagonal? Root over of 10 square plus 10 square plus 10 square means 10 root 3 meter. Root over of length square plus breadth square plus height square. So it will be 10 root 3 meter. Correct? Now, a lizard try to travel from one corner to the diagonally opposite corner of the room by traveling shortest distance. What will be the distance traveled by the lizard?
10 root 10 root
10 root 10 root 5. Why?
So he cannot fly now. So we have to follow this.
So if he will follow this one, will it be 10 root 5? Answer is correct. Explain properly. First of all, diagonal calculation will not give you the correct answer because lizard cannot fly. So he must move over the floor and over the wall. Then what will be the minimum distance in which traveled by him to reach the diagonally opposite point? Should it move over the diagonal of the base and then vertically upward? Then it is not the minimum. How to solve this one? See. The room has how many faces? 6 faces. So let us consider the upper face is removed. Now there are 5 faces. So I will open up all these 5 faces. T1. It is S by V. T1 will become S by V. Okay. Now, in this case, second case, what is given? 2V. So we can write S equal to 2V into T2. So what is T2? 2V. So now we will calculate the average velocity. This is total distance traveled is 2s divided by T1 plus T2. That is the definition of the average velocity or average speed. That is total displacement by total time. Total time is T1 plus T2. Total displacement is s plus another s, that is 2s. Now substitute T1, T2 and calculate. So this will become 2s divided by s by v plus s by 2v. Then you can write v average equal to 2s is there, s by v taken common, it will be 1 plus half, right? Then cancel s. So it will be 2v divided by 1 plus half means 3 by 2. So this 2 will be multiplied in the numerator. It will be 4v by 3. So answer is not the normal average of v and 2v. It will be 4v by 3. Okay. Now, if this type of problem comes, what we will do? Should we solve the entire method and find the answer? No. See, if two distances are equal, this is S, this is S. Suppose here velocity is V1, here velocity is V2. Time obviously different because distances are equal but velocities are different. So it will take different time to cross those distances. In that case, average velocity will be 2v1 v2 by v1 plus v2. It is coming from this formula. If you apply for this general method, you will derive this formula by this technique. So we have to remember this formula and just put the values. In place of v1, I will put v, and in place of v2, I will put 2v. I will get the same result. Again, this is the general formula. See, distances are equal, so this formula is applicable for this problem. What is v1 in this case? V. What is v2 in this case? So just put here and you will get the same result. See, it is 2 into v1 means v, v2 means 2v divided by v1 plus 2. That is coming 4v square by 3v. 1v will cancel, it is 4v by 3. So in the exam we have to use this one, not the entire procedure. So when distance traveled are equal with different constant velocities, then average velocity for that two part will be 2v1 v2 by v1 plus v2. You have to remember this one. Okay. What happens if time intervals are equal? Then directly average. Means, suppose a particle is traveling for 1 hour with a speed v1, then traveling for another 1 hour with speed v2. Then obviously distances are different. Times are equal, speeds are unequal. Means distance traveled are unequal. So for 1 hour it moves with 40 km per hour. For next 1 hour it moves with 80 km per hour. So obviously in next 1 hour velocity is more, so it will cover more distance. In that case average velocity will become simply average of the two. So wherever time intervals equal, average velocity will be average arithmetic mean of the two, that is v1 plus v2 by 2. Whenever distance traveled are equal, average velocity will be 2v1 v2 by v1 plus v2. This is called harmonic mean. Second one is arithmetic mean, first one is harmonic mean. Three types of means are there: harmonic mean, arithmetic mean, geometric mean and harmonic. These two will come. So only remember these two formula. Whenever this type of problem comes, directly use this formula. Just check whether distance traveled are given equal or the time of travel are given equal. And if you wish, you can derive this formula by the general technique. That is already given, I think, in your book or anything. Okay? Now we are going to study the motion in one dimension, that is motion along a straight line. An advantage of doing that is we can forget about all the vector concepts, because motion is taking place along a straight line. So distance traveled and displacement have the same magnitude, speed and velocity have the same magnitude, acceleration is not even changing the direction until the particle reverses the direction. So when the particle reverses the direction, I will put a simple minus sign. No other things to bother with the vector components, all these things, vector resolution, vector addition, all these things we can forget. So that's why straight line motion is most easy. We consider a particle is moving along a straight line. Suppose in certain time t, it covers a distance s. Initial velocity considered as u, final velocity considered as v. Then we can easily write the formula for acceleration, that is v minus u by t. I haven't used the vector sign now because the motion is taking place along a straight line, and from this we can write v equal to u plus v. This is the first equation of kinematics. Similarly, we can derive how many equations? Two other equations. One is s equal to ut plus half a t square, then v square equal to u square plus 2as. Any other equation? Distance traveled by the particle in nth second of the motion. Nth second. Now what does nth second mean? Suppose a particle is moving up to 9 seconds. It crosses some distance in 9 seconds. Suppose I start here and I am going, and after 9 seconds I will be here. Then at the end of 10 seconds I will be here. Then from 9 to 10 seconds, how much distance is covered by me? That is covered in 1 second. Okay. If I am accelerating, then initially 1 second and in later 1 second, distance traveled are not equal, because suppose 4 to 5 seconds, that is an interval of 1 second. 9 to 10 seconds, that is also an interval of 1 second. But 4 to 5 second interval is coming earlier, 9 to 10 second interval is coming later on. So see, if there is acceleration, then in the later 1 second interval, the car will cover more distance because its speed will increase. Now, from that initial point 0, first calculate the distance up to 9 seconds, then calculate the distance up to 10 seconds, then subtract these two, and you will get the distance traveled in 9 to 10, this 1 second. So if 9 is considered as n minus 1, 10 is considered as n, then it is called the distance traveled in the nth second of the motion. Like 10th second, similarly it is n minus 1, that is in the nth 1 second of the motion. So that formula is s nth equal to, simply you can remember like this. This will give you, and in place of t you can put n. So first formula will be un plus half an square. Next one will be minus u into n minus 1 plus half a into n minus 1 whole square. Now you have to subtract. Like distance covered in, suppose n is 10, so distance covered up to 10 seconds from 0, distance covered up to n minus 1, that is 9 seconds from 0, then you are taking the difference, means you are getting the distance traveled in the nth second of the motion. And if you calculate this one, it will come u plus half a into 2n minus 1. U plus half a into 2n minus 1. You can subtract on your own, and this will be the final result I have written. Okay, you can check the steps by calculating it properly. And one more formula will be there which we will frequently use, which can be actually derived from the second one. See, this one is taken as the SNF formula. This is formula number 4. One more. If I write the second equation, I want to divide both sides of this second equation by time. Okay. S by t equal to u plus half a t. Divide both sides by time. Now what is S by t? Total displacement by total time. This is just the average velocity. In which type of motion? Uniformly accelerated motion. U plus half. Now from that equation, what is the value of AT? Equation 1, E minus Q. Just substitute it. So we can write this one as V average equal to U, 2U plus V minus U. So V average is coming V plus U by 2. This is the another equation. That is, average velocity is in uniformly accelerated motion is the average of final and initial velocity. If final velocity V, initial velocity U, any accelerated motion, uniformly accelerated motion, then you just add these two velocities divided by 2 and you will get the average velocity. For all these formulas are valid for uniformly accelerated motion along a straight line. You will write down all these formulas are valid for uniformly accelerated motion along a straight line. This one? Last one? Okay. Not visible. Acha. V average equal to V plus U by 2. Is it clear now? V average equal to V plus U by 2. Okay? Now write down one problem. A car is moving with a velocity 72 kilometer per hour along a straight road. A car is moving with a velocity 72 kilometer per hour along a straight road. Okay. Find the acceleration, find the retardation applied on the car to stop it. Find the retardation applied on the car to stop it within 100 meter. First, write down the quantities which are given. Initial velocity is given 72 kilometer per hour. Final velocity, because it is mentioned the car will be stopped after some time. So final velocity will be 0. Displacement during that time is given 100 meter. And you have to find out the retardation E. Okay? A means acceleration. Acceleration is the negative of the retardation. So that's why A. Negative acceleration means retardation. Now we have to find this value A. First of all, see, all the quantities are not in the same unit system. First one is, this is in SI system. First one is not in SI system. We will convert it. So kilometer per hour, how to convert it in meter per second? 5 by 80. Multiply it with 5 by 80. So it will become 20 meter per second. Now which equation we will use? Can I use V equal to U plus AT? No. Because information of time is not given in the problem. That's why we cannot also use S equal to UT plus half AT square. Because this equation also requires the value of time. That is not given. Then come to the third equation. There is no information of time. Time is not required in that equation. That is V square equal to U square plus 2AS. So we will use this equation V square equal to U square plus 2AS to solve this problem. So once you write all those quantities, you will see that which equation to use and which one not to use. So in these given conditions, there is no value of time given. So that's why the equations containing time we will not use to solve this one. We can use the equation which is independent of time, and that is V square equal to U square plus 2AS. So now put the values. V is given 0, U is given 20 plus 2, A, S is 100. So now we can write that 200A equal to minus 400 and A is given minus 2 meter per second square. So the value of the retardation is 2 meter per second square, and since I considered the plus sign in the equation, means we are calculating acceleration and it is coming negative, means retardation. So no need to change the sign from the beginning. After the solution, you will get the acceleration signs negative. If it is come negative, then it is retardation.
So what if it's a curved road? So what if it's a curved road?
Do the both. Both, then you will get the wrong answer. Either you have to change the sign in the formula, or you have to stick to the original formula and get the sign of acceleration to the it is curved. In that case, then what is the problem? Tell me the entire problem. Okay. A particle is moving So this formula will not work. You have to use the rotational motions formula. This is only valid for straight line motion. Then you have to use theta equal to omega 0 t plus half alpha t square for calculation of that. Okay. Is it clear? Okay. Now, one more problem. A car starting from rest with acceleration, a car starting from rest with acceleration alpha comma moves for certain time, and then with uniform retardation beta moves until comes to rest. Means start from rest, accelerating for some time, then it is retarding and comes to rest. Acceleration is alpha, retardation is beta. If the total time of journey is t, then find the maximum velocity achieved by the car. During the journey. Now, what is the final velocity? V. What is initial velocity?
0.
Acceleration is alpha, time is t1. So from this you can write t1 equal to v by alpha. Clear? Then come to the next part. What is the initial velocity? Final velocity?
0.
So write this equation, final velocity 0, initial velocity v minus, because second part is retardation, beta t2. Then we can write t2 equal to v by beta okay. Now, what is the total journey time given in the problem? T. So can I write T1 plus T2 equal to T? Just now substitute the value of T1 and T2. It is V by alpha plus V by beta equal to T. Take V common, 1 by alpha plus 1 by beta equal to T. Then take the LCM, beta plus alpha. Then V will be alpha beta T by alpha plus beta. This is the answer. First, you have to use the calculate the acceleration part, then you have to calculate the retardation part. From that you have to find the expression for T1 and T2. Then T1 plus T2 means the total time given in the problem T. Then you have to substitute that. Then you can find the expression for beta. Sometimes an additional question comes from this: what is the displacement of the particle during the entire journey? We know that area under velocity time graph. Area under velocity time graph represents displacement of the particle. Means the area of this entire triangle represents the displacement. So we can calculate this displacement by calculating the area of this triangle. What is the formula for area of the triangle? Half into base into height. So here half, height is b, base is, so it is just half bt. Put the value of b, it will be half alpha beta t square by alpha plus beta. That is the answer. So we have already found the expression for v in the first part of the problem. Now if it is asked to find also the displacement, we will just calculate the area of this triangle. That is area under velocity time graph. It will be half into base into height. So base is t, height is v, so area will be half bt. Just put the value of v and it will get your answer. Another problem, write down. A stone is projected vertically upward. A stone is projected vertically upward with velocity 10 meter per second. With velocity 10 meter per second. Find the time after which it will return to the point of projection. Find the time after which it will return to the point of projection. Okay? Acceleration due to gravity is 10 meter per second square, and you can neglect the air resistance. Air resistance is neglected. Acceleration due to gravity is 10 meter per second square. Now solve the problem. How much time? After how much time it will return to the point of projection? First tell me which data are given. Okay. Initial velocity given, that is 10 meter per second square. So we will first write those u, that is 10 meter per second square. Final velocity we will discuss. Acceleration due to gravity is given, that is 10 meter per second square. Velocity is given 10 meter per second. Okay. Now, what else are required? You have to find out the time. Achha, now, which equation to use? Can I use the first equation? V square equal to V equal to u plus at. For that equation to calculate time, I require the knowledge of final velocity. Okay, I will not consider the entire motion. I will first consider the motion up to which it will rise. So if you throw the stone, it will rise up to a height and then fall. What is the velocity at the topmost point? 0. It will come momentarily at rest and then it will fall. Then I can find this time of ascent. This is the time of ascending. That I can find. So I will find that. So I want to find the time of ascent by considering that V is 0 at the top. So this is the situation. It is thrown with u, this is 0 and gravity is downward. Okay. So I use this equation. Final velocity 0. Initial velocity u. Gravity is retardation, so minus g. Suppose time is T1 is the time of ascent, in the time in which the particle go to the top. So we can find this. T1 equal to U by G, 10 by 10, 1 second. So in 1 second particle will reach to the top. So how much time will it take to come down? Gravity, air resistance is neglected, same time. So it will come down in another 1 second. So what is the total time after which it will return? 2 seconds. So if it takes time 1 second to go to the top, then it must take 1 second to come down, because we have neglected the air resistance. So write down, in absence of air resistance, time of ascent is equal to time of descent. So I can write total time taken, T will be equal to 2T1, that is 2 seconds. Okay, this is the solution. After 2 seconds it will return to the point of projection. Is it clear to everyone? The procedure and all these things? Then I will ask you to solve this problem by using S equal to ut plus half at square. Can it be solved by using this equation? V equal to u plus at, using that we can find it. But can we solve this same problem by using S equal to ut plus half at square? How?
Since height is same, so we can apply it.
That height we calculated. Then
But it's 5 meters.
it will lead you to long calculations. I want to use the only equation S equal to ut plus half at square and calculate the time directly. That it will come 2 seconds. Now the vector property is required. See, once you throw the stone from this point, what is the direction of u? Upward. What is the direction of acceleration? Downward. If you throw the stone and after some time stone comes to your hand, what is its total displacement? 0. Because initial and final position coincides, means displacement is 0. So I can now use S equal to ut plus half at square. S equal to ut plus half at square. Just put displacement equal to 0, u is in the upward direction, so positive. How much? 10. T minus half 10 T square. G is 10. So in place of value of A, I put minus 10 because G is in the downward direction. So in how much time displacement is 0? The total time. So that has to be directly calculated here. So it will give us 5T square minus 10T equal to, means T square minus 2T equal to 0. T common, T minus 2 equal to 0. So how many possible values will come? 2. One is T equal to 0, another is T equal to 2. So which one is our answer? T equal to 2. Because T equal to 0 means when the stone is not at all thrown upward. That is T equal to 0. So at that time it is at this point. So it will come again to this point after 2 seconds. So directly you can find from this S equal to ut plus half. So kinematics problem is not that you can use only, you have to use only one formula to solve a particular problem. You can use many formulas to solve a particular problem from different angles. Whatever you feel easier, you can apply. Here, in the second case, I use the logic that when it will come to the same point, its displacement will become 0. Then I can calculate the total time in which the displacement will be 0. Obviously, t equal to 0 cannot be answered. T equal to 0 means the body is not thrown yet. So after certain time it will come, so the other value t equal to 2 will give you the time after which the particle will come back to the same point. Okay? Any question regarding the topic that we discussed today?
So, in this equation, can we write the final velocity as minus 10
Final velocity as minus 10, yes we can write, because if it is thrown with plus 10 and when it is coming down it has the same speed and direction will be in downward direction. Okay, now write down another problem. All the things are problematic. One by one problematic. The engine of a train crosses an electric post with velocity u. Engine of a train crosses an electric post with velocity u. The last compartment of the train crosses the same post with velocity v. Find the velocity with which midpoint of the train crosses that post. Find the velocity with which midpoint of the train crosses that post. Full stop. Crosses that post. Consider that the train is moving along a straight line with uniform acceleration. Consider that the train is moving along a straight line with uniform acceleration. square plus 2s twice. We can eliminate a and s and then we can find this. Suppose this one is an electric post and this one is a train. So when front portion of the train is close to this and then entire portion crosses this. So when a train crosses a post, what will be the displacement of the train? Equal to its own length. So like this and then crosses completely means it has crossed its own length. So whenever any train crosses an electric post or any point, the displacement of the train is equal to its own length. Okay? Clear? Now, three situations we will now draw. First case, suppose this is the electric post, this is the train, the front point of the train in front of the post. So what is the speed of the train now? U. Now when the midpoint of the train passes that post, what is the speed of the train? Say W. I consider W. This W I have to find. Okay? Now how much distance, if the length of the train we consider S, then when the midpoint is crossing, then how much displacement is for the train? S by 2. That is half of the length is crossed. So displacement will be S by 2. So for this I can use the equation v square equal to u square plus 2s. What is final velocity when midpoint crosses? W equal to, what is initial velocity? U square plus 2 into a into s by 2. When midpoint comes, the velocity of the train increases to W from U. So initial velocity U, when midpoint comes in front of the post, final velocity of the train we consider W. And meanwhile, what is the distance traveled? Half of the length. So displacement will be S by 2. So we can write this equation, final velocity square equal to initial velocity square plus 2 into a into S by 2. Now, from this, I got a relation that ES equal to W square minus U square. Let it be your equation 1. Now I consider when the last point of the train crosses this post. What is the velocity now? V. When the last compartment crosses. Then what is the displacement? Complete length is covered. Then total displacement equal to length of the train. So now the displacement is S. So I can use another equation to write this final velocity square equal to initial velocity square plus 2 into a into s. Now for as I have the value from first equation. So I will substitute it here and write v square equal to u square plus 2 into w square minus u square. Now find the value of w. Two cases. One, entire train is crossing. initial velocity u, final velocity v. Total distance equal to length of the train. That is, displacement is s. Another thing is that initial velocity u and midpoint comes, consider the midpoint's velocity as w. Then midpoint when comes, the displacement is half of the length, that is s by 2. So we construct two equations. One is considering initial velocity and the midpoint, another is initial velocity and the last compartment. Then from this as we got, and as is substituted here. Then we can find the value. It will be v square equal to u square plus 2w square minus 2u square. So we can write v square equal to 2w square minus u square, and then we can write w square equal to v square plus u square, then w will be equal to v square plus u square by 2 under square root. This is the answer. A and S are not mentioned in the problem, so I have to eliminate the expression for A and S to find the answer in terms of V and U only. So from the two equations I actually eliminated product of A and S. So again recheck what we have done. Front point of the train when crosses, its velocity u. The midpoint crosses, its velocity w. So velocity increases from u to w due to acceleration. And when the midpoint up to midpoint crosses, the displacement of the train is half of its length. When the midpoint crosses, then it is s by 2 displacement. Okay. Apart from this type of problem, there are some problems in one-dimensional motion related to calculus. So we will discuss one or two such problems right now. Position, time equation, position time equation of a particle moving along x-axis is given by t equal to root x plus 3, t equal to root x plus 3, where all quantities are in SI unit, Okay? X is the position along x-axis and t is the time. And these are related as t equal to root x plus 3. Find the position coordinate of the particle when its velocity means instantaneous velocity, when its instantaneous velocity is 0. Position time relation of a particle moving along x-axis is given by t equal to root x plus 3, where all quantities are in SI unit. Find the position coordinate of the particle when its instantaneous velocity is 0. Instantaneous velocity means t x dt. In x along x-axis, if it is x-axis only, then it is dx dt. Generally dr vector dt. Derivative of position vector with respect to time. Achha, all of you who are present here in class 11th and 12th, there is in science curriculum there is math is one of the subject, or someone left the math as a combination. All of you have math. What are the combinations in CBSE, NCERT syllabus? Physics, chemistry, biology and mathematics. Or except mathematics, some can take computer and all these things. How many of you don't have math? Acha. Okay. So others may not have any difficulty in calculating the derivatives and all these things. This equation, this calculation requires a very little bit of derivative. Just only derivative of x to the power n, that is n x to the power n minus 1. Only that formula is required. Nothing else. Zero. No. Only allow. No, by zero, zero. It will be at the origin. See, x coordinate is the position coordinate. Here time is given as a function of position. But for doing the derivative with respect to time, I have to convert this equation in a format where position is given as a function of time. So what we will do, first we will write it in this manner, that root x equal to t minus 3. Root x equal to t minus 3. Then squaring both sides, we will get x equal to t square minus 16 plus 9. That is actually t minus 3 whole square. So t square minus 16 plus 9. Clear? Now, first we have to calculate the derivative. dx dt means the instantaneous velocity. Derivative of t square will be 2t minus 6, because derivative of t with respect to t will be 1, and this is a constant term whose derivative will be 0. So this one is the instantaneous velocity. Okay? After calculating the derivative, that is rate of change of displacement with position with respect to time, that is giving us instantaneous velocity. Now in the problem it is given that to find the position coordinate where instantaneous velocity is 0. So put this instantaneous velocity 0. You will get 2t minus 6 will be 0. So t equal to how much? So at 3 seconds, the instantaneous velocity will become 0. Then what will be the position at the 3 second? Just put it t here 3. So we have to find that this position at t equal to 3 seconds. That is x, in place of t I put 3. The particle will come back to the origin because x will come to be 0. So particle moves like this and again come back to the origin. So first, what is given? T given as a function of x. So that's why first we convert this one to write it as x as a function of time. So the equation comes x equal to t square minus 60 plus 9. Then for calculation of the instantaneous velocity, we calculate the derivative dx dt. It is giving us 2t minus 6. Now it is given that we have to find the position of the particle when its instantaneous velocity is 0. So first we have to find that time when instantaneous velocity is 0. So instantaneous velocity dx dt I put 0. To find the time when it will become 0. That time is 3 seconds. Then 3 seconds, what will be the position coordinate that is required in the problem. So in the equation for x equal to t square minus 60 plus 9, I put t equal to 3. And putting t equal to 3, it will give x equal to 0. Means the particle's position after 3 seconds will be at the origin. So when displaced instantaneous velocity is 0, particle will be at the origin. And one more thing, acceleration when we write. Suppose we are considering one-dimensional motion. Okay, motion along x-axis. We consider the one dimension and direction is taken along x-axis. So acceleration can be written as ABDT. This can be written in another format also. How? By invoking this one, dv dx into dx dt. As if these dx are cancelling out. Incremental displacement or differential displacement, that is cancelling out. So you can write this one in this format. Do you know the name of this technique? Where we invoke this dx and dx 2 times. It is a rule of derivative. Chain rule of derivative. Correct. Now this dx dt can be written as velocity, instantaneous velocity. So this acceleration can be written as v times dv dx. So both of this, you can use this formula for acceleration, this formula for acceleration also. V dv dx, that is also acceleration, because dx dt can be written as v, so v into dv dx.